Hey student, here is the outlines for this lectures. We're gonna cover three sections in chapter 2022, but mainly we're gonna focus about the Ohm's law and how we apply it for basic stuff for electric circuit. So the starting point here talking about the Ohm's law, which definitely everyone is covered in lab in the physics before, and the mainly thing for the ohms, if you wanted to write down to find the connection between what we have covered in chapter 20 and 21, start from a charge, and charge lead us to find electrical field. From the electrical field, we end up with the electric potential. From electrical potentials, moving charge or the charge rate lead us to find another parameters. We call it current, which is basically the rate of the charges. Now the Ohm's law talking about the charge and electric potential, which basically electrons or basically charge move. Okay, that's how you connected all those parameters together. And the Ohm's law, straightforward the formula, just stated that the voltage, the current, sorry, the ratio of the voltage across the element and the current, they are they're gonna be the linear relationship. Okay. And that relations, the slope of that line, we call it resistance. So the resistance is just the electric potential divided by I. So as a unit, so we can type it volt divided by amps. So it's the same unit, we call it ohms this time. Here is the first example, straightforward, like real life. Imagine if you have light bulb and you feed that light bulb with the 120 volt, and you are given the light bulb has 60 watt, and you are given the current for that light bulb, and they ask you for how much the resistance of that light bulb that lead to generate that light that we're gonna see it as the heat or as the light. So basically this one is straightforward since we have the I and we have the volt. So this one is straightforward, Ohm's law. V divided by I. We have the volt, it's 120 volt, divided by zero point 0.5 amps. So the light bulb resistance is 240 ohms, or volt divided by amps. It's the first example here. The second example that we have here is we have the light bulb, and the battery use it for to this flashlight bulb. A flashlight is 3 volt, and the resistance, it has 6 ohms. And the question here asks for the charges. Charges move. So mentioned before, the charge move means current. Current means movement of a charge, delta Q divided by delta T. So to find the delta Q charges, I need to find I. So from here, delta Q, it will be I times delta T. So to find the delta Q, I need to find I. For I need to go back to see the informations. I have volt and I have the resistance. So I can use the Ohm's law to find the current. From that relations, I can find out, or I can rewrite the equation as a function with the R and volt, and I have the basic informations. I have here is the 3 volt divided by 6 ohm. So we end up with the 0.5 volt per ohm, or that's what we call it amps. Again, amps can be written as volt divided by ohms, can be written as this formula here, coulomb per second. So all of them the same formula, or we can call it amps. Now I found current, so I can go back to find the delta Q, which basically I have zero point 0.5. Since I have the time, so I will write it down column per second times how many delta T. I have 10 minutes. Here is the 10 minute. I need to this one to the second. So I have 60 seconds in 1 minute. So I have minute cancel with the minute. I have 600 second cancel with the second. I have 600 divided by 2, end up with the 300 column. So all that's straightforward relation. And this we're going to deal with more in chapter 23, but here just to give you the indication or the test how we imagine those resistance to amps and 4 amps, they are light bulb, for example. So I have the source or the flash light, and they are connected together. So the connections here, we call it series. The series connections here, if we just a quick reminder for the current, or what we call the conservative current, the current is conserved. So the current goes in this path and go across the R1, or what we call 2 amps, and go out and enter the 4 amps and go out and go back. That's one. So basically current, I'm talking about the movement of a charge. So the current here is still the same current. Here is the I, is still 0.25 amps. So basic in that, I have, if I go back to the Ohm's law, R, just delta V or V, or the voltage across 2 points, that's the volt, divided by I. So I asked me to find the voltage difference. Here is the R times I. Okay. Now the only thing it is still the same current in through the R1 and through the R2. So basically, if I wanted to find delta V 2 ohms in the 2 ohms here, R 2 ohms times the current constant 0.25. Okay, so 2 times 0.25, you end up with the 0.5 volt. Similarly, delta V in 4 amps, 4 amps times 0.25, 25 amps, we end up with the 1 volt. And basically delta V, which delta V I'm talking about, here is the delta V. Delta V, it should be equal delta V in 2 amps plus delta V in 4 amps. We are done here, guys. The delta V across the R 4 ohms, 1. The delta V across the 2 amps, 2. Here's the conservative of the voltage 2 in the series. The voltage is still divided to the series resistors. So I have here is the 1. Here is the 0.5 volt plus 1 volt. I end up with the 1.5, which is the same thing as my source voltage. Last example here, just quite different here. We're given the filament power with the 100 watt for light bulb, and we given the current is 0.83 amps, and given the regular voltage supply, which is 112. The first one is the A. Ask how much the resistance. Straightforward. Ohm's law. R voltage divided by I. I have voltage 120 volt divided by I 0.83 amps, and this one 140 44 something, but in the resistance we put as the integer number, so this one is the ohms. The second one, what do we have? We have the wire with basic informations about it. the charge go through the wire, and the wire will give some information through the L, and it has cross sections area. We call it A, and we have the material of that one. It has a resistivity. What we call it here is the rho. So they're asking to find out how much, basically this information, how much length that the wire it will be to provide me the 0.83 amps for the light bulb feeded by 112 volt. Okay, so the first one, let's find the A as the area, which basically pi r square or d divided by 2 square. Where is the d? It is diameter here. So I have here is the pi times 0.035 times 3 minus, and this one is meters, divided by 2, and here is the square. I end up with the value, it is 9.6 power to the minus 10 meter square. What the equation that we need? We know how to find the resistance as a function of the resistivity times the length divided by area. So from here, I have rho, I have r from A, I have A, I just calculate. So I can type my L as a function with that. Okay, it will be r times A divided by rho. So I have all the informations. R, let's type this one here. R, which 144, 45 ohms times A, I have the A 9.6 power to the minus 10 meter square divided by rho. I have the resistivity here is the 5 power to the minus 7 ohms per meter. So I end up here meter square cancel with the meters, ohms cancel with the ohms. We end up with the value 0.28 meter. That's the length requirement for this problem. Okay, basically just be careful for the formula that we use, and you have just 2 or 3 formula you can apply with it to find what you asking you to find. Okay, I am done for this lecture today, and thank you so much, guys.